Hello everyone. I hope you're enjoying the morning presentation. So today I will introduce you the use of Sigmafine in the gas transportation and distribution industries. We'll start discussing about the industry forecast for the next years and the natural gas value chain. And then I will focus on Sigmafine application and advantages and benefits. So the gas is projected to be the fastest growing fossil fuel. The International Energy Agency is expecting that the gas will grow at least of 1.6% in the next decades. And among all the fossil fuel, also in the case of low carbon emission, the use of the gas, natural gas, will continue to grow. And if you think about this growth that has been a lot in 2017, was pushed by the Chinese economy and the continuing European recovery. So the reason are the economic growth. So the more the economy is growing, the more energy we need. And also the global gas supply is changing, so LNG is taking more and more importance. And also government policies that are pushing a lot the use of natural gas, also above all for low carbon emission. So these are some examples about the continued demand of gas. So Chinese demand grew of 150% in just 1 year, and China surpasses Japan as the largest LNG importer. It's true that China is bigger than Japan, but Japan is an island, so it's quite interesting, this point. And in the LNG are happening big investment from countries and companies. Australia became the largest LNG exporter, and US doubled its LNG exportation in 2018. If we talk about pipeline, the Trans-Adriatic pipeline has been connected with the Anatolian pipeline. So this is a big pipeline, and the idea is to bring gas to Europe from Azerbaijan to Europe, passing through Italy. And the connection is between Turkey and Greece. And then the natural gas pipeline that will connect Russia to China is nearing completion. So this is the natural gas value chain. We have the gas production. Some of you for sure know about it. So the most interesting pipelines are the gathering pipelines, small pipelines, low pressure, and they are moving gas from gas production to gas processing plants. We have transmission pipelines, big pipelines, high pressure that are moving gas internationally. And we have distribution pipelines. So these distribution pipelines are managed by a local company, and they are bringing gas from the transmission pipeline through a city gate to home and businesses. So maybe what you don't know is that Sigmafine is currently used in the gas production, in the gas processing, in the liquefaction and regassification. What maybe you don't know is that Sigmafine, we are working to close the chain, and we want to apply Sigmafine on transmission pipelines and distribution pipelines. So what you see here is just some of the industry needs. And even if you are from other different industries, maybe you will have the same needs. So what you need, I will go just through some of them. You need an efficient management of your production processes. You need to aggregate and analyze your data. You need to provide the reliable KPI and the integration with other solutions. So how we apply Sigmafine to this industry? First of all, we have to create a topological model of the gas distribution network. So we want to represent in Sigmafine the physical plants that are installed. Then we reconcile the data with the goal to minimize the overall measurement errors. And the goal is to run a network balance, the estimation of unmeasured flow rates, the monitoring and the estimation of losses that you can have in the pipeline, the generation of KPIs related to processes, sensors, emitters, the tracking gas ownership, the business process integration, and the data distribution to third-party application. So the first 4 points are correlated to mass balance analysis. The tracking gas ownership is back allocation, the one that was mentioned in Marco before, and the latest 2 points are IT integration solution. So now I will go through some example of the application. This is a city. I removed the name, but probably you know which it is. And we have 3 different types of pipeline. We have low pressure, medium pressure, and high pressure pipelines. And the user are connected usually to low pressure pipeline and medium pressure pipeline. So with Sigmafine, we will focus on medium and high pressure pipelines. So we will remove the yellow pipeline, so we won't consider it. So the nodes in the distribution network. Sigmafine works with a logic of element. So we have to identify different elements in order to create a model in Sigmafine. The first one is the city gas station. Is the first step where we have the first pressure reduction step. The second one is an intermediate pressure reduction station. And in the end, we have the final gas pressure reduction station. This is the latest stage where the pressure is reduced to the level that at the level that we receive the gas at our houses. So for each element, we can acquire different data. What you see here in Sigmafine, they are called attributes, but these are the characteristics that we want to get from our plans. So it can be the pressure, the input pressure, the output pressure, the temperature, but can be also other information, like my door of my room is open, or another example, I can measure the time of a specific condition. So if my pump 1 is on, I can measure how many hours this pump has been on. I can apply this concept also, for example, for meters. And in Sigmafine, if you have a lot of these city gas stations, you don't have to create every time one of these with these attributes, but you define a logic of templates. So you will generate each single element based on a template. And if you want to change something, you can change at a template level, and you will find the new attributes at the element level. Here we have other 2 examples related to other elements with different attributes. So as you can see, you can configure according to your request. Now we'll talk about the application of Sigmafine for gas distribution network balance. So we have the transmission pipelines. I remember is high pressure, big volumes, and then we have a city gates, and then we have distribution pipelines. So we will focus on the network balance on the distribution network. We have physical measurements. We have for sure the city gate because it's changing the ownership of the gas. And we have physical meters at home and businesses. So one of you maybe will recognize these meters. I have one of these in my house. But distribution company install also maybe other meters that are not physical, but they use to manage the network on other area, on the pipelines. So, which is the gas balance equation? It's the input minus some gas consumption that you have during the process to preheat the gas, minus the output should be equal to 0. But often it doesn't happen. So the reason is because you have losses on your pipelines, you can have illegal connection or also meter failures. So what is doing Sigmafine? Sigmafine take the same equation, but he put it equal to 0. So we get how it works. We get the raw data from the field, from the meter, from your database, from your IT infrastructure. We apply a near real-time reconciliation, and we reconcile the data. How we do it? Through a model. This is a screenshot of a part of a model. So you see it's a physical representation of a network we have the input, we have the city gas station, then a measurements, and then other elements. What you see in black is the measurement of the flow on the pipeline. What you see in blue is the reconciled value coming from Sigmafine. Which are the benefits? First of all, the distribution of the imbalance is based on meter accuracy. So through our model, we distribute the imbalance to each measurement point according to the accuracy of each sensor. The frequency of the analysis is defined by the user. So the user defines if he wants to run in near real time, maybe hourly, daily, monthly, and it depends a lot of the frequency that you acquire the data. So if you acquire the data just once per day, it makes sense to run the analysis daily. Then, when you run a case through Sigmafine, you will know immediately the total imbalance of your network, but also on each single element. So we are moving from a high level. Then we can go a little bit more in detail. So you can identify the imbalance area where the discrepancy is occurring. And in the end, you can know also which meter is failing, because the Sigmafine, through this algorithm, can quantify the difference between the measured value and the reconciled value. And when it's very high, this difference, the system will tell you. So you will know after the analysis which meter is not working on your plant. Sometimes it can be difficult if you are managing a big area. The next example is related to the estimation of unmeasured flow rates. So we have our pipeline. This is transportation pipeline. We have our city gas station. And then we have some businesses connected to the network, districts, or maybe a single house. And we have a pipeline that brings gas to the transportation. So here we have the change of ownership from the transportation company to the distribution company. And then we have the gas that is going to the business, to the district, and to the houses. And we have meters in some point of the network. So my question here is, can I estimate the gas in some area of your pipelines where you don't have the meter? We are not considering the single houses, as I told you before, but we will consider in our analysis at district level. And the answer is yes. So using boundary condition, you can estimate the flow rate in different pipelines when you don't have sensor on it. The benefits. So if you know the flow rates on boundaries pipeline, you can estimate the value in a specific pipeline. You will have economic savings because you don't have to buy new meters, you don't have to install it, you don't have future maintenance, and something is related as important to safety. So you don't have to go physically on a pipeline and install a new meter. And in the end, Sigmafine can support you in the future if you want to do an investment, install a new sensor on the pipelines. You can identify the best location for new meters based on measurement redundancy to help the algorithm in order to increase its accuracy. The latest example is related to ownership tracking. So it's the case where we have multiple suppliers to multiple users. So this is an example for a transportation company. And we have the gas that is moving from different vendor to different user. There can be different companies, distribution, or maybe it can be the same distribution company, but with different networks. And here we want to ask, how can I track the ownership of the gas? So Marco before spoke in his presentation about back allocation, about talking about the upstream sector. We can apply the same concept to the gas transportation industry. So we can quantify the percentage of the gas that is coming from vendor A and then that has been distributed to the user 1. So the benefits in this case of Sigmafine is that it allows the correct assignment of the gas consumption to the gas suppliers. So This is to close my presentation. We will go through the advantages and benefits. The first point is the analysis of the near real-time information coming from the field through the algorithm, and in order to increase the accuracy of your data. And it's important, the reconciliation period. So you can define inside Sigmafine the frequency that you want to run the analysis. The second point is to expand the Sigmafine functionalities. So I mentioned in my presentation a few examples, but you can apply Sigmafine to run other analyses like quality tracking or eating value estimation. So if you want to estimate the eating value, and you can analyze the composition of your gas, you can quantify this value based on the mass calculated through Sigmafine. You can calculate the efficiency of equipment through Sigmafine, and when I was mentioning before, you can calculate the operative hours of a pump, of a boiler. It can support base maintenance monitoring, and you can, using the PyAF structure, you can implement advanced engineering calculation. You can share the data calculated through Sigmafine using dashboard and reporting like Power BI, Tableau, PyVision. And very important, is the scalability. So you can start with a model of 250 elements and move it until 25,000 elements. So Sigmafine can run its analysis in the period of day, hour, on a different model with different sizes. So you can start creating a model on a specific area and then expand the use of Sigmafine to other areas of your network.